planets that we can see in the universe. So, our topics are the theories, types of the solar system, types of universe, and the sounds and cosmos. So, the first is the different theories. So, the first one is geocentric theory. So, from the word geo, which means the land or the earth, then centric or center. So, it is also known as the Earth-centered universe. So, it was proposed by Claudius Ptolemy, a Greco-Roman astronomer, mathematician, and geographer, and he believes that the Earth is stationary at the center of the universe, and all celestial bodies, including the sun, moon, planets, and stars, revolve around it in circular orbit. So, Ptolemy suggested or says that the Earth stays still at the center of the universe. Then the sun, the moon, the planets, the stars revolves around it. So yung Earth daw, siya so yung Earth is nasa center daw ng Okay, so yung yung Earth is nasa center ng universe. Stay still lang siya, na siya gumagalaw. Then yung mga planets, minsan yung moon, yung nag-revolve sa Earth. Wala ka daw. So, yung mga celestial bodies daw, like the sun, moon, and planets, ay nag-revolve sa Earth in perfect circle motion daw. Perfect circle daw yung ano nila, pag-revolve nila. So, people at that time, it makes sense to people at that time because every time they look at the sky, they can observe that it seems like everything was revolving around it now. So this story is rooted in the ideas of earlier Greek thinkers like Aristotle, who argued that Earth must be the center because it is heavy and immovable. So this story is based on the philosophical basis from Aristotle's idea that the Earth is the heaviest object, so therefore it stays at the center, while the lighter things like the celestial body, sun, planets, and stars moves around it. But later on, Ptolemy noticed that sometimes the planets moves backward during the night sky. So to explain this, he said that the planet doesn't revolve only in a big circle but also in a small loops called epicycle in that circle. However, as astronomy advanced, scientists noticed or they noticed that it doesn't, or this theory, which is the geocentric theory, doesn't really explain the complex motion of the planet. So it gives it leads to the development of the heliocentric theory. So from the word helio, which means the sun, centric or center, so it is called the sun-centered universe. So it was proposed by Nicolaus Copernicus, a Polish mathematician and astronomer, formally introduced the theory in 1543 in his book De Revolutionibus Orbium Coelestum, or on the revolutions of the heavenly sphere. So he believed that the sun is at the center of the solar system and the Earth and other planets revolve around it. So Copernicus proposed that the sun is at the center daw. So the sun is at the center of the solar system, hindi daw yung Earth. So basically, kabaliktaran lang siya ng geocentric theory. He explained that the Earth is actually spinning on its axis and revolving around the sun. And while the planet also has its own paths in revolving the sun. And this idea challenged the old belief, which is the geocentric theory, that the Earth is the center of the solar system. So in the Copernicus model, day and night happens because Earth moves around once every 24 hours, and the season changes because it revolves around the sun every year. And he also said that the strange backward movement is just an effect of the Earth and other planets orbiting in different speeds, and the unnecessary loops daw are yung na effects lang siya kasi the Earth and other planets, iba yung time frame nila sa pag-orbit, not sila same ng kabilis kung paano mag-revolve around the Sun. So some supporters of this theory is Galileo Galilei. He used the telescope to provide observational evidence, and also Johannes Kepler. He refined the Copernicus model by showing that planets move in elliptical orbits. So this is also known as the Kepler's law of planetary motion. So Johannes Kepler is a German astronomer and mathematician. So his theory is built upon Copernicus' heliocentric model, and he explained planetary motion more accurately than Ptolemy and Copernicus. And it has 3 laws. So the first law is the law of ellipsis. So according to this law, planets move around the Sun in elliptical orbits with the Sun at one focus. So this proved the earlier belief that planets move in perfect circles. So according to this law planets move around in an oval-shaped path, not daw in perfect circle, with the Sun slightly off to the center. So as you can see, oval-shaped yung pag-move ng planet at hindi perfect circle according kay Kepler. Then the second law is the law of equal areas. A lone drawn from a planet to the Sun sweeps out equal areas in equal times. Means that the planets move faster when closer to the Sun, which is called perihelion, and slower when farther, which is called aphelion. So this means that the planets change speed as they orbit. They move faster when they are closer to the Sun, and they move slower when malayo daw sila sa Sun. And the last law is the law of harmonies. So it is the square of a planet's orbital period is proportional to the cube of its average distance from the Sun. And it shows the mathematical relationship between how long a planet takes to orbit the Sun and its distance from it. So the third law shows that planets farther away from the Sun take much longer time to orbit than to the planets closer around it. So it means that the farther the planet is on the Sun, the slower it revolves. For example, yung Earth, which is closer to the Sun, it only takes 1 year to complete an orbit. On the other hand, yung Saturn, which is farther to the Sun, it takes 29 years, specifically 29.5 years before makomplete na yung orbit. So imagine yung gap nila. Sa Earth is 1 year lang, yung Saturn 29 years before. So 29 years talaga siya before matapos na. So mahina talaga yung pag-ikot ng Saturn. So this explains the third law of motion. It is the law of harmonies. The farther the planet, the slower it revolves, and the closer the planet, the faster it revolves around the Sun. Okay, so the fourth one is the Newton's law of universal gravitation. So it was proposed by Isaac Newton, an English physicist and mathematician. He introduced this theory in Philosophiae Naturalis Principia Mathematica. And he believes that every object in the universe attracts every other object with a force of gravity. So Newton says that everything in the universe pulls on everything else with gravity. And the strength of this pull depends on how heavy the object is. The heavier the object, the stronger it pulls, and the farther the object is, the weaker it pulls, or the weaker it gets, rather. So gravity is a universal force acting everywhere in the universe. The force of attraction increases with greater mass and decreases with greater distance. So gravity works everywhere in the universe. So the pull gets stronger if the object is heavier, and the pull gets bigger if it's farther apart. So this is the formula, which is the F is the force, the G is the gravitational constant, M1 mass of object 1 and M2 mass of object 2, and R distance between centers of the masses.
Kanino ang equation na?
Sa para malam ng first kay Isaac Newton.
That is the force experienced by two different bodies on each other. So it is directly proportional to the mass, but it is inversely proportional to the distance. Okay? The farther they become, the lesser is the gravitational force. The closer they are, the stronger it is. No? And take note, let's say for example, if you're going to compare the force that we experience tayo at yung Earth is the same amount of force that the Earth is experiencing from us. Because pareho naman tayo, M1 tayo, M2 siya. Ganon din. If you're going to compare the force that the Earth experiences from us, ganon din. No?
So the next one is the nebular hypothesis. So it was first proposed by Immanuel Kant. He says that the sun and planets form from a common cloud of gas. But later on, expanded by Pierre-Simon Laplace, he expanded Kant's idea into a detailed scientific theory. So they said that the solar system formed about 4.6 billion years ago from a large rotating cloud of gas and dust called a nebula. And under the pull of gravity, the nebula collapsed, flattened into a spinning disk, and began forming the sun and planets. So the nebular hypothesis says that the sun and planets are na-form daw sila by a huge cloud of gas and dust. Then over time, the cloud span flattened and clumped together. The sun is at the center, and ang mga smaller clumps daw, ito yung mga ito ay nag-form, and ito na yung mga planets. Then around 4.6 billion years ago, meron giant cloud of gas and dust, and ito yung tinatawag na nebula. And nag-collapse daw ito because of the gravity, and it flattened into a disk, and the center became the sun, while yung mga leftover materials, which are the small clump, ito na yung naging building blocks of planets. And there are processes on how the nebula form. So the first is the collapse of nebula. So gravity caused the gas and dust to contract. So yun na nga, yung nebula daw is nag-collapse because the gravity pulled the gas and dust inward, so making the cloud shrink. Then second is the formation of the sun. So most of the material accumulated in the center, igniting nuclear fusion to form the sun. So most of the material formed from the center ay moved to the center where heat and pressure built up until nabuo ang sun. And the third is spinning disk. So the remaining material spread out into a rotating disk. So yung mga leftover gas and dust, nag-spread sila yung sa flat spinning disk, and makikita sila around the sun. Then the fourth one is the planetesimals form, or the dust and gas clump into small bodies or planetesimal. So yun na nga, yung mga small clumps, dito na nabuo yung mga planets. Tapos yun na. Yung mga planetesimals or mga small clumps daw is nag-collide at nag-merge to form the planets, moons, and other solar system bodies or celestial bodies. So that are the formation process of the nebular hypothesis. So the next one is the planetesimal theory, and it will be discussed by Isna.
So today we are going to tackle about planetesimal theory. So if you look up on the night sky, humanity has gazed at the stars, and they wonder, how did all of this come to be? So those single profound question answers to the engine of cosmology. And when we say cosmology, it is the science studying the evolution of the universe, its formation, and its ultimate fate. Today we are going to tackle about different powerful theories that wanted to explain the origin and history of our cosmic revolution. Okay? Now let's tackle about planetesimal theory. So our journey begins close to home, which means that the planetesimal theory explains how planets, including Earth, came from the dusty, they were born from the dusty remains of a young star. So a death of a young star can cause life to many of planets. And it starts with a rotating cloud of gas and dust called the solar nebula. So which means the solar nebula is the reason of many planets forming, colliding with each other to create the known size that we know today. So planets form from smaller bodies called planetesimals, or planetesimals. A rotating cloud of gas and dust collapses into a young star surrounded by a protoplanetary disk. So as this cloud collapsed to form our sun, the together slowly stumbling into kilometric-sized bodies called planetesimals. So over millions of years, our planets, these planets, have been, with the force of gravity, they have been colliding and attracting each other, which makes them form different planets. So next is the Big Bang Theory. When we say Big Bang Theory, this refers to the beginning of everything that started 13.8 billion years ago. So it will make you wanted to question, where did the solar nebula came from? Where are the materials that made the solar nebula in that form? So to answer that, we must look at the beginning of everything. So it posits that the universe began approximately 13.8 billion years ago from an extremely hot condensed singularity and has been expanding ever since. So there are theory that posits or solidifies this idea. It starts with the idea of Hubble's law. They said that the universe or the galaxy is moving away from us. That we understand ever since from the beginning, the universe has always been expanding. And the idea of cosmic microwave background, where the after faint glow of Big Bang that permeates all the space that we see till now. So the Big Bang Theory is one of the most dominant models that we see, that we learn. So the origin and evolution of the entire universe. Hubble's law refers to the observation that galaxies are moving away from us, proving that the universe is expanding, and the afterglow of the Big Bang, a faint microwave radiation permeating all space. Now, the second one, the steady state theory. You should also understand that the Big Bang theory was not always the only idea that is there. There is this major alternative that can battle or it has the opposite of Big Bang, which means that they said the universe, according to steady state theory, the universe has no beginning, nor it will come to an end. So in large scales, the universe has always been unchanging and eternal, that forever it will be remain the way it is. So that steady state is a challenging idea to the minds of the people. So it's like an idea of an atheist, because however, the idea behind the steady state theory, it has no theory that can solidify its idea. Unlike the Big Bang, it has the Hubble's law because the universe continues to expand. Unlike the steady state theory, everything is steady, which means everything has always been there. which means having no beginning and no end. So it has been maintaining its own density, it has been remaining in that way, and so it is. So at the end of the day, we can still say that the Big Bang model will always be the dominant idea before any model that has been proposed by any of theorists. So the next one. It is an alternative to the Big Bang for the origin of the universe is eternal and changing on large scales. So spontaneous creation of matter, a few atoms per cubic kilometer per century to maintain the constant average density as the universe expands. It expands, but it has no beginning. It expands, but it has no ending. That's the steady state theory. So the next one is the inflationary theory. So the Big Bang theory has some robust, it had some fossils, which did not explain, because there are certain things that inflationary theory wanted to explain. The specific or the precise numbers, how did the universe come together? So the inflationary theory was a theory that wanted to give details about the initial condition of the universe, which means it suggests that the first fraction of a second after the Big Bang, from about 10 to the power of negative 36 to 10 to the power of 32 seconds. There is this one video that I was very fascinated. A lot of theorists, they were arguing that if ever there was that the creation of universe was late 1 second, then no life could have been created. Or if ever the creation of the universe was early, a second, then there could have been no life created. Which means there should be a specific, precise number for that Big Bang to be created. So this inflation solves problems like horizon problems. Why does the geometric patterns of universe remains flat? So there is a number behind it. Why those things appear to be like that? So that is one of the ideas that solidifies that inflationary theory is a good idea. Not just a good idea, but rather it is one of those foundational ideas that makes us understand the Big Bang. So the primary focus of supplement to the Big Bang theory explaining its initial conditions. So the horizon problem is why the universe is so uniform in temperature in all aspects or directions. So the flatness problem, why the geometry of the universe appears flat. So the next one is the black hole theory. Black hole theory, this is one of the gravity's ultimate victory. Okay? So from the universe birth to its mysterious phenomena, so the black hole theory actually is rooted from the general theory of relativity by Einstein. So this is one of the most extreme and fascinating predictions of modern physics. So this refers to the black hole theory focuses on region of time and space. It is when a gravity that is so intense that not even light can escape from it. So it happens when a matter is compressed into a tiny volume, so tiny that it creates a boundary called the event horizon. So this refers to the cosmic vacuum that can warp time and space. This occurs when matter is compressed into a volume called the event horizon.
Saan galing yung black hole?
Black hole is formed from the death of a star, but that star isn't just any stars. It is a massive star that is composed of even thousands of suns, a size of in our solar system massive star. And when that death of the massive star begins, then it can create so much heat to that, it creates black hole. So black hole are those entity that sinusubsob yung basta,
Nihila niya.
hihila niya, even light, nothing.
So for black hole to happen, your star must have enormous energy on the first place. Kasi kung mahina na yung star mo, tapos namatay lang siya, it is not considered to be a black hole. It's just a dead star. Okay? So for it to be a black hole, during its lifespan, it must have or it must contain enormous amount of energy. Not because it is very big, it's bigger than the sun that we have, but hindi siya yung pinakamalaki. But ang energy niya ay napakalaki. Napakalaki. Kaya siya magiging black hole eventually.
And then I've seen a video, this scientist, they would argue that how will the universe end? And some of the scientists, they have proposed that the universe will not end in a single Big Bang, but it will end with a creation of many black holes. Which means once the black holes will start eating other parts of the universe, and they will start forming and colliding with each other, which leads us to the end of the creation of the universe. And that results to the creation of multiple black holes. And how will a black hole die? I don't know. If they collide each other, then that will create another big black hole. But there is this one thing that I understand. It will come to an asset,
If you will study the life cycle of a star, that is where your black hole will actually ano yung next na mangyayari? Pag naging black hole siya, ano yung next step na niya is the amount of energy it will absorb again will be enough for it to parang i-trigger ang maging start na ulit. No? So, but it will remain a black hole for quite some time. It has not been observed physically because wala naman tao na kabuhay na mas matagal pa doon sa black hole. But literally, that is the explanation of the black hole. No? Para mga red giant, meron niya mga ganyan. It will magsiseparate, it will form two groups of stars hanggang sa maging, yung isa maging dead and black hole. Tapos yung black hole mag-evolve na naman maging star.
so it will release energy.
I believe it's when it will be able to absorb enough energy to trigger it and become a star again.
So the last one is the multiverse theory. So with this theory, they would say that our universe is not the only one existing, which means there are potential diverse universe that exists out there. Different sets. So the multiverse is a hypothetical set of many potential diverse universe that comprise all sets of reality. So later, in our report, you will learn that there are this
One
idea.
universe, it's just an hypothesis, a multi-universe. But a universe consists of very different galaxies. Okay? That is why there is only one theory on the creation of the universe, which is the Big Bang Theory. It all started from there. Tapos, nagkaroon ng different galaxies. So, depende rin ang galaxy, will also depend as to the formation of it. No? So, but it will be, I think it's still being part, it will still be explained by other members.
Yes. So this idea isn't a single theory, but arises from others, like inflationary cosmology, suggesting different bubble universe. And later on, you will learn about what are bubble universe.
At again, these are just theories.
So,
Hindi pa
it's
natin na mayroong separate universe.
It challenges the very definition of what we learn, what we know as reality, which pushes the boundaries of scientific inquiry. So the conclusion behind it is that the conclusion from that is that from the slow, steady accretion of planetesimal to the explosive birth of the cosmos and the speculative existence of infinite parallel realities, these theories represent humanity's best attempt to answer our oldest question: where did universe came from? How did life began? Thank you very much. Now we are going to proceed to our game called Factors.
Okay, so the class will be divided into
Big Bang.
Familiar ba kayo sa two factors?
Sana.
Di ba na-ito kayo sa naman? So the class will be divided into two groups, and each group has two representatives. So mag-ask ako ng questions, then nakatalikod yung dalawang representatives. So pagkatapos ko mag-ask ng question, mag-count ako 3 seconds, then pagkatapos ko ng count, napagsabay kayo magharap, then yung answer, sabay na lang sabihin. Pag hindi nyo sabay na sabihin yung answer, wala kayong voice. So for example, yung tanong ko, what is the English of mansanas? 1, 2, 3, bacol.
Banana?
Sa ibang universities na.
Bigyan ng jacket yan.
Okay guys, so dapat sabay yung sabihin yung tamang answer para may voice kayo. Sige na, count 3. 7, 8,
So, tatlo, apat.
1, 2,
Sabi ka lang yung sila.
1, 2, 1, 2, 5. Bakit ba nila sino yung group?
Okay.
Okay kayo. Or kung saan yung count
So, pwede na.
sige na. So, pili kayo dalawang representative.
Amanda and Ken.
Go, Jess. Ano ba yung tingin na yun? Ano tayo si Jess?
So, 5 questions lang
Group
meron.
2 ka na. Bakit ko lang mag-isa na yung group 2?
Group 2, isa na nila group. Kumpleto ang group 3.
So, okay, so ready na guys?
Ano po? Kayo magkasama? Naramali yung group 2.
So, okay, ready na?
Na.
Dito na representative.
Okay.
Go, Jess.
Go, Jess. Go, Jess.
Group 1 ka yung group 2.
Jess.
Okay lang. Kaya yun naman yung ginawa nila.
Banana.
Banana.
Sino representative?
Go, Jess.
Si Axel.
Let's go, Jess. Kayo ko lang ba? Jess. Ano ba yan?
Practice. Ano ang English ng
Manzana.
banana?
Eh, bawal yung sabihin sa isa't isa na pagsama nyo lang.
Answer ko?
Practice, okay? So, what is the powerhouse of the cell? 1, 2, 3, go! Okay, ganyan lang ha, dapat sabay.
3 seconds ba?
Okay, so, ready na? Okay, so, who? Game begins. Ready na, one. Now, one, ready na. Who proposed the heliocentric theory? 1, 2, 3, 4, 5, go! Okay na yun. Basta. Pwede mag-iisip lang. Sige na. Second question is, what is the theory that says that the Earth is at the center of the universe? Again, what is the theory that says that the Earth is at the center of the universe? 1, 2, 3, 4, 5, go! Sabay, sabay na. 2, 1. So third is, so this refers to the theory that states that the beginning of everything is from a single explosion. Again, so this theory states that the beginning of everything is from a single explosion. So 1, 2, 3, 4, 5, go!
Big Bang!
Sabay na. Sina 3, 2.
Amen.
Mistake.
Sige na, fourth is, this refers to the theory that is rooted in Einstein's general theory of relativity. Wait lang, meron sa keyword. Wait lang. Sige na, 3 counts na parang, 3 counts na lang ha. So, which refers to the cosmic vacuum. Again, this theory is rooted in Einstein's general theory of relativity, which refers to the cosmic vacuum. It means, iikot niya lahat. Sina, 1, 2, 3, go!
Black hole.
Sige na, let's score na ba kayo? Una.
Two.
Next meeting na pa.
Nicolas Copernicus.
Sabi man si ano, si Ken.
Yung report na nasa